Hey all you fiends out there in YouTube land, I got a video for you today showing you a problem I have, and that problem has to do with this guy right here, this P1. And the problem I have with the P1 is kind of straightforward. Dummy rounds, not real. Loads into the chamber just fine. Actually, it shouldn't be doing that. That's actually kind of interesting. The reason why it shouldn't be doing that, I'm missing a very important part that's called the extractor. If you look at these guys right here, so get a close-up, that was actually ejecting the little dummy rounds here. It should not have been ejecting them because it's missing the extractor, which is nothing more than a hook. Flip it around that way. It's a little hard, well, it's very hard to see actually. But there's a hook right in there. What that hook does on an extractor is it hooks around the rim of this shell. You can barely see it, which is that's the extractor hook right there. So that's grabbed onto that rim. Anyways, long story short, this P1 doesn't have that, and the reason why it doesn't have it is because this was bought as a frame, and then every single piece for it was bought separately in order to assemble the gun. The reason why the grips are white, I'm on the process of making my own grips. I've made a mold of the original P38 and will cast, and this obviously is not a good cast, this is just a test for coloration and stuff like that. So long story short, I got to make that part today, and I'll show you my process. Okay, first thing I want to do, this is an original P38 slide. It has the ejector already in it. This came assembled. It's a Spreeverk. There's a video on this pistol in particular if you guys want to look at it later. But in this case, what you want to do is get under there, and hope you guys saw that. Just put the screwdriver under there, pull that out, push back, pull out loading indicator. That just lets you know you have a live round in there. Rear sight comes off. Spring. Firing pin block. Drop safety. Firing pin retainer, firing pin spring. Now if you look down in there, if you can look down in there, there's a little nubbin right there. And what you want to do is get a punch. In this case I'll just grab a brass punch because they're on hand. Push. You can see that has popped out a bit now. And shoot it across the room like I just did there. And have your plunger fly out. I think the spring flew out. That's the spring. Sorry guys. That happened really fast. That's called self-disassembly. It's a... You thought it was a modern feature of cars today. But there you go. That's the spring back down in this tunnel here, putting pressure on this tunnel, back in there, putting pressure on the ejector. Alright, so after the fiasco of searching for this thing, which was lying out in the open the whole time, I found it. Didn't take that long, it took me a minute or two. So what I have to do is I have to make this piece, that piece, and this spring. And they are quite small, to say the least. Which is a bad pun, which was not intended. I can tell you right now, the tricky part on this is going to be this little nubbin here. I'm not sure why it's narrowed, but I'm going to do my best to make it exactly the same. The most important thing, obviously, is going to be function. This section is pretty straightforward, so I'll show you the next step in what I do in a case like this. Alright, we need a book. We're going to use some measuring tools. I do have here a micrometer. Probably overkill in this case, but doesn't hurt to use. I'm sure I could probably just get away with the standard calipers, but I'm going to use the micrometer today. It's a small part, so it shouldn't be a big deal. Ooh, that's blowing out. Alright, so this is my sketchbook here. Sketches. And then I'll do these little things here. This is actually just a printout from a little thermal label printer. Ideas. I don't know what that is. I'm not sure what that was. I was probably drunk when I did that one. So we got a nice clean page. First thing I want to do is put the piece on the paper and trace around it. I don't think this is necessary, but it's a nice little reminder. And then what I'll do is I'll draw a larger, not to scale version. So now I have a larger, not to scale version. The pin, I don't think I'm going to bother tracing. It's a little on the too small side. But what I'll do is I'll place on the paper and just do kind of like a little enlargement of it. Again, not to scale. It doesn't need to be to scale. Close enough is close enough. And the spring, I'll probably just actually do a quick trace around the spring. You could count each individual coil, which isn't a bad idea. Especially if you're doing something that needs to be exactly like the original. For the sake of work. This is just going to be a range pipe for me. So if it fails to eject, no biggie. It appeared the battery is dying. This. Give me a minute. Alright, so new batteries. Zeroed the thing out. I'm not going to make you guys watch me measure everything. The other important thing too is the depth. So I'm just going to kind of fake a drawing here. Anyways, so that represents that from the side. So I'll show you briefly how to take a proper measurement with one of these things. You have your gross adjustment, which moves it a lot. And then once it's a little bit snug, you switch over to this between 4 and 6 clicks. I have my measurement there, as you guys can see, which I can't because it's wrong. So I'll draw a little line here. And I'll draw it in at 3.447. Those are millimeters, by the way, guys. Sorry, Americans. I will not be using imperial under a millimeter, or really even under an inch. I won't be using imperial. I like using metric. That's what we're supposed to be using in Canada anyway. So, alright guys, so that's basically how you use a caliper. I'm going to disappear and I will show you how I take the measurements. Or I'll take the measurements and then we'll work from there. Okay, so I got all the measurements down on the piece of paper. It looks a little chaotic. It's mainly for my reference, not for you guys. This is more detailed than I need. This would be if I was going to make the part in 3 dimensions, like on a CAD program. But it's nice to have too much information than too little. I think everyone can agree with that. 0.337 there. Actually, you know what? I just completely lucked out on this one. 3.5. That's pretty much what I was looking for. So, what I was going to do was just kind of sand this down and make it a little thinner, but I don't need to do that. So I'm going to put my book aside. And to start with, there's some errors on the end of this here. You can kind of see there's an edge there, so that's not going to be any use. So I'm going to place my part further down the line. And I can do one of two things. I think what I'm going to do here is I'm going to blacken the entire piece of metal with the... So just blacken that like so. So I'm going to place it like so. Hold that down with my finger, and I'm going to take my metal scribe, which is this guy here, and I'm going to trace just like I did on the paper. So you can see there now I have a shape. I'm just going to come in and clean that up a little bit. Okay, now I have that part cleaned up. Time for step 3, in which this is the part that's not hard. I'm going to see if I can rearrange the camera to show you what I'm about to do, but I don't think I can simply because I'm going to have to take it to a grinder. Okay, I've grounded off the top part here to match this curve. It's a little easier to see when I flip it over. So that's matching that curve. So the trickier part with this one is going to be hollowing out this little bit of area here. So what I'm going to do for that is I'm going to throw this into a vise and make some rough cuts here and here, and then I'll figure out how to nibble out the innards there. So next up. Okay, as you can hopefully see here, I just did some straight cuts down. That's the existing line for the scribe I did. So they're not quite touching, but they're close. So I have to figure out how to get rid of this metal here. For that, I'm probably going to switch over to the Dremel and grind away. I'm sorry there's no videos of me hacksawing. Everything's attached to this one table, and it looks like an earthquake on film. So give me 1 second, and I'll set up the Dremel, and I'll start grinding away. Alright, so I have a diamond grinding bit set up here. It's pretty much the same as using a file, except for it's way faster. I don't want to do the finishing with this one. I will take hand files and finish this off. Sorry guys, I'm going to have to do this off screen. Guys, simply because I cannot hold the tool and get the camera angle you want. So I'll be back. You can kind of just see what's going on there. Should hopefully make quick work of it. Alright, that didn't take too much grinding. You can see I'm pretty much on that white line I wanted to stop at. So the next part will be grabbing some hand files and having at it. I'm going to double check my measurements and probably mark out a bit in more detail. Ow! I'll tell you one thing. Grinding, things get hot. Don't ever forget that. Ow! Got my thumb. Burnt my thumb off. I won't be able to pick my nose no more. Alright, things are starting to look a little bit better here. That hook is pretty much what I call done. I know it doesn't line up perfectly on the camera, but I think it has more to do with the metal finish than anything else. But pretty much done there. So now I have to focus on the back end, and particularly this little section here. For that, I'm not going to worry too much yet about here, but I will start shaping the inside section. And for that, I will go back to my Dremel and use this piece here. Or I could be using my round diamond file, which actually is probably that's not round, but the round diamond file is probably a better idea. So I'm going to do the round diamond file. Okay, we're getting there. You can start to see the resemblance. So now what I have to do is I have to cut this back part here, and I got to be careful because there's a couple different angles going on. So there's a step right here that I got to be careful of, which is indicated right here. So I'll just make another mark just so I know where my step is, so I don't accidentally grind too far. Alright, so I'm going to take this over back to that grinder and lop off the majority of this and then come back and finish it up. Alright guys, as you can see, it really is coming along at this point. So angles match pretty good. You can see there's a bit of white showing right along that line right there. That's the leftover material I have. You could also see that chamfering I was talking about. That this piece does not really have that yet, but that will be the last thing to do before I call this piece close to finish. And I say close because there's still a matter of heat treating, which is actually quite simple on the part this small. So we're going to get on to working this piece, and for that I'm just going to straight up use Dremel sanding bit to finish the process. This is also the part where you're going to want to start taking some extra measurements to see how close you are. So I think I got those angles pretty darn good, I would say. One way to visually check if you got the part right is mirror them. You can see there, that's actually pretty darn close. Measurements help too. I know I'm in 0.25 or less. So there you go there. If anything, this hook's a little bit sharper, but that's not a big deal. It will wear with time. These parts are wear parts, so eventually going to be replaced. I don't know why they're so hard to find online. So the last thing I still need to do is I still need to add a bit of a recess to there, and I'm not 1000% sure why that's there, other than perhaps to reduce friction. I don't know, but so for that I'm just going to go back to this little guy here. I'm going to go through my well, you can see that's actually pretty close, I would say, to matching that contour. So I'm going to stick with this, and I'm going to notch that out. So I'll be right back. Okay, so I say I'm done finishing the major part of this. Machining-ish. Machining. I guess it's machining. Hand machining. Kyber pass machining. So all I have to do now is I'm just going to take some superfine sandpaper and just make sure there's no burrs or anything on this that are going to catch when it's installed in the pistol. And then I'll have to heat blue it. Not heat blue it, that's not my goal, but have to heat temper it, which will actually blue it, but I'm going to put a cold blue on it anyway, simply because I want to finish this. I find heat blue doesn't really last that long. So, clean up time. Alright, the part's all been cleaned up, and we're getting ready to heat treat it. So to heat treat it, I'm using a torch, and I'm using MAP. I like MAP. MAP is the stuff in the yellow bottle. Propane is the blue bottle. MAP just gets a little bit hotter, and yeah, it just gets hotter quicker. So if you notice, it just kind of got dark. I turn off the light just so you guys can see the heat process. What I want to do is, that's noisy. What I want to do is heat this thing up to the point where it becomes red hot. And the trick to doing this is not catching your shed on fire. Glowing red. Dip it in, enjoy the smell of burning motor oil. This is motor oil, by the way. I didn't case harden this like I do a lot of my old parts. This is a high carbon steel, so it will take heat treatment quite well. You don't need to do anything extra to it. And there is the part that is now hard. You can do that classic well, okay, don't do it with a diamond file, guys. That was stupid of me. A normal file. It's now hard. And it just flew away. So the last part to make is going to be the little plunger. And I'll show you. That's going to be down and dirty quite easy. So we'll get to that in just a second. Alright, so now I have to make this little plunger here. So what I want to do is find... This is just a cheap screwdriver, or not screwdriver, drill. And see, that's about 3 mil. This guy here, about 3.3 mil. So what I'm going to do is I'm going to take that sander, and I'm just going to plug in my drill, spin it, and touch it up against the grinder, and it will act pretty much like a lathe, but quite a bit more delicate. So the idea here is I have 2 marks, so that's my length of the pin. And that's just my safety mark. Like I want to pretty much even that all out to one length, and then I'll come back, mark it again, and turn down the second half of the pin, which is the smaller. Alright, so I now have the step. A little hard to see. Don't have anything to put behind it. So you can see that step in the pin is there. The pin is turned down to the outer diameter. All I did was to make sure that edge was a little bit extra sharp. I just did the same process of spinning it in the drill, but I used a file just to help define that edge. So when you put the spring on, it has a rest. It's not going to slide all the way. You don't want this to be too wide either, because if it is too wide, it will change the diameter of the spring, and it's not going to fit in the gun properly. So this part is pretty critical to get right. To be honest, it's probably a little bit big. I think I'm going to take that down a little bit more with some sandpaper. But so far, so good. Throw it in there. I'm going to take it back to the drill, and I am going to give it that little point that's on here. Be right back once more. Point has been added. It's now pointy. Last part for this piece is to heat treat it just like I did the first one, the first big piece. Moving on to that. And that's how you heat treat. Small parts are quite simple. You can even do this in water. I kind of like water for small parts because it cools it down a lot faster. Anybody who's watched, Forged in Fire knows, don't ever quench in water. Well, that's true for knives and large pieces, but small pieces, they're not going to have the same problems. All right. Okay, so the last thing I need to make is that spring. For that, this is what they call piano wire. I don't know why. I guess it's probably used in pianos. But it's spring wire. It's 1095. I believe it's 1095. You can get it from a hobby store. You can get it from anywhere. It's not a big deal. I know a lot of gun supply places like Brownell sell it. I think you're probably going to be paying more. As soon as you attach the name gun to anything, you charge twice as much, right? Everybody knows that rule. So in order to make this spring, this isn't just another piece of piano wire. It's a little undersized. It's 0.01 mil. I want 0.25, but I'd rather go undersized because I find when you wrap this wire, it tends to become a little wider when you take the tension off of it. You want to stop these down to pretty much as far as they go. Then you take your two pieces of, you take your core and you take your wire, like so. Sorry, everything's getting messy. This is not the way to work, guys. This is a bad example. I'm going to start losing parts if I'm not careful. So, clear off the work area just a little bit here. You take your vice grips or clamp, whatever you want to use. This is the tricky part. Clamp them together. Then you take the wire you want to be the spring and you start twisting it. The first couple twists are going to be very loose. Just keep tension on it. Keep wrapping. Don't worry. I like making the coils as tight as possible, like pretty much touching. I'm not trying to mimic the look of the spring just yet. So I just keep wrapping and wrapping. Like so. Now, in order to get the spacing right, I'm just going to eyeball it. You could count each coil, but it is a critical component, but not as critical as some other parts. Grab the pliers. This is where I get the length out of the spring. I just kind of pull it like that, and you can see it starts to pull the coils apart. That actually looks pretty close to me. So now I just unclamp it. And I will tell you the hard part about this spring is actually cutting this stuff. It's very tough. And my cutter is not here right now. So I will cut it with my imagination. What am I going to cut this with, guys? Okay, spring has been cut. You can see the ends don't look right. That's a really simple thing to fix. Hope you guys figure that one out. Just throw it on the, just hit it with some sanding. And all right, cleaned up the spring there a bit. Now I have flat ends to work with. Gonna check the size again. You can also probably notice that the coils on the new one, which is the silver one here, are a bit thicker, which means it's going to be a stronger spring. Shouldn't really make a difference. It'll probably put extra wear on the on the ejector I made, but it's not going to hurt it. Well, it might hurt it, but just wear it out sooner as opposed to factory. All right, so spring, plunger, those go in. Now for the truth. You know what I forgot to do was oil this. That's exactly not what I want. Something's going on here. Something's going on. I think what's going on is my angle there is off. So instead of forcing it back in, it's forcing it back out. That's what that so it's not a hard fix. This time I remember to lube that up a bit. I recut this angle here, so it has more of a slope to it. Force it in. Feels good. Good tension. Fits flush. Sticks a little bit on the back, but not a big deal. Now that should be a working ejector. we see more gusto when it comes to ejection is the question now. In. The whole top part just came off, guys. One of them days. Alright, let's find those parts. Uno mas. Will it stay together? In. Looks good to me. Looked good before. We won't know until they take it to the range, though, will we? So, homemade ejector. Was it worth it? Hell no, it was not worth it. Wow, that does not look right. Okay. Done. Ejector built and installed. Problem is, I got another one to go. And the question was that worth it? The answer is no, that was not worth it. Anyway, no, it wasn't worth it. That was a lot of work. Would I have rather have found the part online and paid $20 for it? Yeah, it's definitely worth $20 worth of labor. Is it worth $100 worth of labor? No. That little guy there, not worth $100 worth of labor. But it can be done. If this was a rare pistol, it's a great example of how to get it done. The technique about turning round pieces in your drill on your sander, that's very valuable. I mean, that is what I use for making screws. I'll take a bolt, something with a plain head, and I will round that out. Same process, put it in the drill, round it out, and then you can cut your slot, make screws. So that technique has a lot more than just making simple things like pins. So keep that in mind. I'll hopefully be showing you here. In the meantime, I really need subscribers, so guys, please like and subscribe. I'm every week there's a new guy, so thank you very much, whoever you guys are who are new to the channel. I appreciate every single viewer, and I don't think just because you're the first you're the best, but hey, if you were the first, you are the best. Anyways, guys, please like, subscribe, comment, and I'll keep doing these, and hopefully I'll have more in the future. Thanks again, guys, and I will see you in the next video.